Welcome everybody to the Sprecher and Schuh webinar we've got today. I want to thank you for coming. I hope everybody's staying safe out there. Rich Lassere, my partner's also on the line, supporting us in this one. Your phones are all muted, so you'll need to use the chat box if you have questions. And we'll be monitoring it, and we have different parts of the presentation where we'll be able to stop and answer those questions. If you notice, there's a section where you can see the handouts we've got. So there's one on this presentation if you want a copy of that, and a couple more that Jason's given us to give out to you. And we'll be sending out a certificate of completion about 24 hours after the seminar. So with that, Jason, I'll let you take it away.
Yeah, right with us today we have Jason McCoy. He's a product manager at Sprecher and Schuh in Houston, Texas. And Jason, thank you so much for putting this together, and we look forward to this presentation. All yours.
All right, appreciate it. Thank you to L3 for inviting Sprecher today. And the topic that we're going to discuss is motor circuit controllers and application guidance. And okay, so here in the US, I use the term motor circuit controllers. It's kind of unique in that the people in Europe like to call them circuit breakers. Well, they're not actually, UL don't like to call them circuit breakers. So the title is kind of pointed in that, hey, yeah, it's a motor circuit controller. So again, introducing myself, I am Jason McCoy. Product manager for Sprecher and Schuh. I've been with Sprecher quite some time, so you will get me if you call in for technical help on the power products, so we can have discussions if you like. So that's kind of the introduction. What's on the plate today? What are the objectives? Well, I've got 4 objectives that I want to cover to kind of convey the point. I want to make a comparison of the traditional understanding of a combination starter versus compliance to the requirement of self-protected type E. So I just want to kind of compare that and see, applying rules, traditional versus type E. So that'll be one objective. We're going to talk about, okay, well, what does Sprecher have to offer from motor circuit controllers? We're going to differentiate the selection options within the KT7 controller product scope. Thirdly, we're going to, okay, what are some of the unique products? We're going to summarize the advantages of KTV as in Victor 7, which allows a solution on the load side of a VFD when you have multiple motors on the load side of one VFD. So that's kind of unique, and I wanted to cover that in this presentation. We'll cover that. And then lastly, okay, regarding all these controllers that we will be talking about, what are the SCCR advantages? How do I identify what the actual SCCR rating of these products? So we'll kind of dip into that so you got an understanding. So, like John had said, we're going to utilize a chat perspective. If you have any questions during the presentation, you could type it in the chat, and we're going to have a separator in between these objectives and kind of talk about if there's any questions. So initially starting out on objective number 1 of, okay, let's establish what's a traditional versus self-protected type E. And what I've done on the screen is give you some visuals. Pictures are always nice, in that from a traditional sense, I'm getting the point across that, hey, from a traditional, I've got a disconnect, some sort of a disconnect, plus a contactor, plus an overload relay. So I've got 3 components. Okay, visually on the screen on the far left, I've got a flange style combo. Flange style, the handles on the side, you can see a circuit breaker feeding down to a contactor, feeding down to an overload. That's a flange style. Right in the middle of the screen, I've got a combo, traditional combo circuit breaker plus a contactor through the door style. The handle's not on the side. Down at the bottom, I got it through the door, visualizing a fusible disconnect in that picture, and then an open type on the right, just visually, just reiterating what we're talking about. Here's a disconnect, here's a contactor, here's an overload. So that's what we're defining as a traditional combo starter. As opposed to, okay, visually, what does a self-protected type E combo starter look like? Okay, we'll get into some of the specifics here in just a minute, but from a visual perspective, on the left side of the page. Yeah, I've got a controller only. I've got a KT7 controller only that complies with self-protected compliance. So yeah, ultimately that is a combo starter, and we'll discuss how that achieves. But yeah, that device by itself is a manual combo starter. In the middle, okay, here now we've added a contactor to the bottom side of the controller. Okay, up at the top, I'm saying, okay, KT7 controller does indeed comply with self-protected Type E rules. And what I'm saying is, hey, that contactor added onto the bottom is merely for convenience of sending a signal, of sending a remote signal. So that's what the contactor is for. Okay, so there we've got a nice economical quick starter, combo starter here that aligns it this way. And then as we get into the Hoffman hinge closure, industry standard kinds of stuff, no longer are we vertically aligning this stuff. Now we're putting it on the same DIN rail just because of the way dimensional layouts of industry standard enclosures are. So visually, I showed you how I had a 3-component starter, and it could be a 1 component if you don't need a signal sent to it, or it's a 2-component starter from a Type E, self-protected Type E. Well, doggone it, what does that E mean? What is E indicative for when we say self-protected Type E? Well, from an electrical control construction standards or construction identification, there's a letter code that I've got on the screen that A through F from an electrical control letter code, not to confuse or mix up with a motor design criteria. That's a different category, but from a letter code, from a construction perspective, they say a Type A combo starter is something that's inclusive with a fusible switch. Type B is something that's going to be inclusive, that's going to have short circuit protection. Type C and D are the circuit breaker type of a combo starter, circuit breaker plus a contactor plus an overload. That's what Type C and D is. Then we get down to Type E and F. Okay, Type E is what we're highlighting today, and that sure, a Type E self-protected combination starter, it can comply, and we'll talk about how and why. But it may or may not include a contactor. If you don't need an external signal, and if you are okay with manually walking up to the device, then yeah, KTA7 by itself complies with self-protected Type E. Then, as in a description of Type F, now we're adding on a CA7 contactor as in a Type F. So, hey, there's a letter code for this, and this is what Type E really categorizes as. So, okay, a real quick brush on background information, just so that everyone understands from a National Electrical Code perspective that a branch circuit is the circuit conductors between the final short circuit device and the motor load. So this is the circuit that we're showing on the screen. So identifying all that, breaking down all that individually. Okay, I've got the disconnect portion squared, and the disconnect is, hey, I have the ability to apply power or take a power away, and from an app motor perspective of, hey, I've only got the disconnect portion. An app motor perspective, I need to be within 50 feet and within sight is what National Electric Code says. So if I'm a branch circuit, hey, I've got to have means of disconnect. So I've got to be able to turn it on and off. In addition to the disconnect, right up under the disconnect, the circuit requires that I've got to have some sort of a protection. And we call that the BCPD, branch circuit short protection. And that could either be a fusible switch or a magnetic circuit breaker of some kind. Now, I did show that separately as in, okay, that could be an app motor UL 508 without any kind of protection. And this could be a fuse block separately. However, moving on to the next slide is saying, hey, that could be all in one, meaning that could be a fusible switch to where you have cartridges that plug into your fusible switch and the fuses go in there. Or it could be an MCP circuit breaker where it already has the magnetic armature with the toggle switch and means of disconnect. So that could all be all in one. So Okay, so that could be one. Getting past the upstream disconnect and protection portion, now I'm moving down into the controller portion. The controller, okay, I've got a motor starter circled here. The controller is the contactor with the open contact here. And the overload protection, National Electrical Code says every load needs an overload, so there's your overload, just to complete the basic concept of a circuit. Now that I've identified the basic concept, let's apply how we can say self-protected type E does the job for us. So redefining in the National Electrical Code figure 430-1 identifies the illustration of all the necessary means of, hey, at the very top, it's got to have some sort of a means of disconnecting. So on the right-handed margin, okay, from a disconnect perspective, I'm breaking down the comparison of, hey, how would we comply with a disconnect from a traditional means versus a self-protected means? So from a disconnect, yeah, the traditional means, hey, there's going to be a handle. There's going to be a ways of turning on and off the disconnect. So the handle takes care of that. That's from a traditional. Now from a self-protected type E, okay, there's a rotary knob on the front of it, and there's a padlock feature that says, hey, I can lock that out from a code perspective. But yeah, the rotary knob on the front of a KT7 complies with the means to disconnect power. Moving down to the next section of what's required in code. Code says, hey, I need some sort of a branch circuit protection device. Okay, comparing from a traditional perspective, hey, in a circuit breaker, there's that magnetic armature on the inside that gives us that short circuit protection. In a fusible switch, there's the fuses that gives us that short circuit protection. Well, okay, in a comparison, how does the type E device accomplish that? Well, yeah, there's a magnetic armature within a KTA, KTB, KTC kind of 7 kind of device. So yeah, there's a magnetic armature there on the inside of these controllers. So that's what complies with BCPD. Moving down in the circuit of National Electrical Code that says, hey, we got to have some sort of a controller for a magnetic starter. So from a controller perspective, comparing traditional versus self-protected. Hey, in a traditional circuit, that's where your contactor comes in. That's what in a traditional, I said, disconnect plus contactor plus overload. The contactor is your controller. From a self-protected type E compliance to the controller, hey, well, that's what the KTA7 does. It is a manual controller, meaning you have to walk up to it and use that rotary knob, but you get the means of opening and closing contacts of a controller. So that is a manual control. And then lastly, National Electrical Code says, hey, I need an overload for this circuit. Okay, how do we comply with that? Right-handed margin from a traditional sense. Yeah, traditionals have to insert an actual overload connected to the load side of a contactor. That's how you comply. Well, from a self-protected type E compliance, hey, there's integral thermal bimetallic overload protection built into the KTA7. So it's in the device. So, I mean, taking code requirement and applying, okay, do I do a traditional? Do I do self-protected? That's what the comparison looks like on this page. So, okay, let's finish up with code. Let's finish up with code and say, okay, what were those code articles that we were talking about? On the right-hand side of the page, I'm saying, okay, the illustration up here I got a fuse disconnect feeding the contactor, feeding an overload. That's classic combo starter. Article 430-52 gives us those justifications. And then additionally, MCP, there's my means of disconnect. There's the magnetic armature on the inside. There's the contactor. There's the overload. So that is a classic combo starter. However, the Article 430-52C6, as in you getting the nuts and bolts of 430-52, it provides you an alternative of applying the rule of self-protected combination controller. Visually, on the left side, I've got a KTA7 only. I've got means of disconnect. I got magnetic armature on the inside, and I've got an overload relay symbol here. As opposed to, I've got the same device, and if I want to send it a remote signal, I'm adding a CA7 contactor so I can send a signal to the coil to energize the coil of the contactors. So we're using the C6 kind of a rules. C saying, hey, I've got a rating or setting. 6 as in self-protected combination controller. And there's the verbiage from actual NEC down there at the bottom saying how a controller is compliant. So that's the actual code for self-protected type E. I'm going to pause for a second and say, hey, maybe even a poll question from a polling perspective. How useful was the explanation of type E in that situation? Or maybe have you guys, were you familiar with type E to begin with? So anyway, I'll kind of pause for a second, see if there's any questions.
Jason, yeah, we had one question that I think you're probably going to cover later, but I'll ask it anyway.
Okay.
What's the KAIC rating of magnetic armature was the question.
What KAIC rating of that?
He asked for the armature.
I will say that in a KT7, there is a magnetic armature and there's a magnetic response current. And it's the setting of that magnetic response current that gives us that branch circuit protection. I'm not sure if I'm actually covering the question, but that's kind of how the KT7 is manufactured or designed. Let me move on and see if I can cover it in some of these other slides. So I'll move on to objective number 2. In that, hey, I want to get familiar with what some of these motor controllers that Sprecher and Schuh has, and just from an offerings perspective, I got to say everything that we're going to be talking about here is in the section F in our catalog, in our E catalog on online and stuff. But from an offering perspective, there is a KTA, KTB, KTC, KTV is in Victor, and KTU is an underdog. So what are the differences between those? I'll have to say that KTA is probably the most popular controller in that is what is consistent of a two component type E starter. Typical magnetic trip setting of 13 times the inrush current. So KTA includes a thermal overload relay. 2-component starter. Moving downward to a KTB, well, what's the difference? Okay, on a B, we took out the overload in that KTB is somewhat analogous to an MCP circuit breaker in that, yeah, it's got magnetic sensing on the inside. However, there is no overload protection to it. What we've done to KTB is merely remove the overload out of it so that an overload can be attached to the load side of a contactor, creating a 3-component starter, 3-component type E kind of a starter. Well, heck, why would we do that? Why would we take out the integral out of the controller and give it down below? Well, there might be a couple of circumstances of, hey, what if I got multiple starters and I needed a dedicated reset? Well, adding an overload and putting a remote reset module on the overload allows you a dedicated reset. Well, what if I needed some extra protection features such as thermistor protection or ground fault protection or something like that? Well, agreed. Changing it to a KTB, adding a CEP7 overload, full featured overload at the bottom, and adding a protection feature to the side of the overload accomplishes that. So it kind of explains why a KTB7 exists. Moving on to a KTC7, which is basically the same thing as a KTA7. Whoop, I got a typo on the screen, and that it's a 2-component starter. And it's just like a KTA7, except now I've got a higher inrush current. So let's say I'm using a KTA7, but I'm using it on a function that has a a higher inrush, or it takes a longer period of time to come up to full speed or whatever. But the higher inrush would be a circumstance of selecting a KT7. So the higher of a 16 to 21 times the inrush current. So that would be a resolution for higher inrush, or things that take longer time to come up. So those KTA, B, and C are very similar products. KTV is in Victor. I get an opportunity to dive into it on the next objective, but I'm just acknowledging, hey, KTA, B, C, and V is in Victor are UL 508 approval devices. So those are 508 devices. And then bottomly on the slide there, I've got a KTU as an underdog. And hey, actually that carries a UL 489 circuit breaker approval. So that is indeed a circuit breaker. However, I got a slide later that says, hey, I can only go up to 30 amps, and that is for non-motor loads. So I'll kind of explain that in just a second. Moving on. Of all these motor controllers that we just talked about, I'm just going to generically say that, hey, we got all kinds of accessories. We've got handles and shafts. We've got lockable knobs that go to the direct front of it. We've got auxiliaries and trip contacts. We've got shunt modules and undervoltage trips. And we've got bus bar and supply blocks to be connecting. So we've got all kinds of accessories that fit all of these ranges. One of the accessories that I kind of want to highlight, being that we're talking about self-protected type E, is that you really got to know how you're applying the product. And if indeed you're applying the KTA7 like or using type E rules, UL gave us a redirect back in 2001 that says, hey, you guys need to kind of pad the line side or give it a 2-inch creepage space. So if you're going to use our device under type E rules, you're going to have to accommodate for some sort of a 2-inch creepage space, in that if it's an individual circuit, you're going to need to use a -TE, KT7 something TE adapter piece that provides that 2-inch creepage space to where an arc from one pole can't reach over to the other pole. So that's kind of a unique, got to kind of be aware that, hey, if I'm going to use type E rules, I need some sort of a space in between the arcs, and that, okay, if I got a single device, I can use a TE adapter. If I got multiple devices, more than likely I'm utilizing bus bar with a feeder block feeding that bus bar, and that bus bar feeder block does comply with a 2-inch creepage space, and a TE is not provided. We just got to make sure you've got that extra space off the top side of that line side device. So, all right, and then so I'm going to describe the loose components of individual contactors or individual motor controllers. Now, if I were to add contactors to the bottom of these, I can call them CL7 assemblies. CL8 is in a miniature contactor, because to the far left, I've got a miniature contactor attached to the bottom. So I got miniature contactors, got regular contactors. Honestly, we can do a CLU as in reversing, because shoot, we could use a mechanical interlock to the side of that contactor and add another contactor for a reversing circuit. And I can have a reversing combo starter in this vertical alignment kind of assembly. It's merely a convenience that Sprecher and Schuh offers these one assembly numbers that are inclusive of your motor controller, your connector, your contactor, your line side type E piece. And if you get large enough in size, now we're going to provide a mounting plate for it if you get larger in size. But agreed, we've got CL assemblies and CK assemblies. I gotta say, a CK assembly is the same thing as a CL assembly, but CK says, hey, I'm gonna put some plastic covers over the front of it, and I'm gonna provide some TBs at the bottom of it, and I'm gonna use a meter seal to give it that perspective of factory assembled. So that's kind of what CK7 is all about. And visually, I gave you the description of a 3-component starter using a KTB, and that's what I've got on the screen here is what we're in one assembly number. We call it a CLT7. T as in Tango says that, hey, we're going to add an overload relay at the bottom of that assembly. And now you can kind of envision, hey, if I use a full featured overload at the bottom of that assembly, it provides a port to where I can plug in specialty features like ground fault and thermistor, and heck, I can even do Ethernet IP on the side of that. So that kind of opens up the options, just kind of letting you know what a CLT7 is. And then up to now, we were talking about open components. Well, Sprecher and Schuh offers catalog page offerings for enclosed components of KT7 enclosed, or if I add a contactor, now I'm calling it a CX7. So, man, we can close these kinds of products in whatever integrity type requirement that's needed for the atmosphere. We've got IP rated plastic inexpensive enclosures. We've got metal enclosures. We've got fiberglass 4X enclosures. We've got type 7-9 explosion proof enclosures. So given the circumstance and the requirement, absolutely, we could house that assembly. So visually, what are we talking about here? I keep talking about a traditional 3-component starter versus a type E 2-component starter. Hey, what do we talk? Visually, we're talking about reducing the physical size of a combination starter. Hey, when you reduce the size, you're reducing all that metal of the enclosure and the cost of the enclosure. And hey, when I go from 3-component combo starter down to 2-component, now I'm reducing the number of components and the cost of the components. So I just kind of, it hits you in the face of, hey, I can reduce the physical size and the cost of a combo starter, dependent if I can keep it at 45 amps and under. I'm going to hesitate on the offering of KTA7, KTA, KTB, KTC. And is there any questions on this product before I move on? All righty. Moving on. That was the product offering. Okay, something a little more specific here in that.
Jason, sorry. Just so you know, a bunch of questions about VFD when you get to that section.
Okay, all right. That's a good segue into VFDs. I'm moving into objective number 3 to talk about VFD, and that we got this unique controller in that if there is a VFD, then the need of one VFD controlling multiple motors on the load side of that VFD, well, let me introduce you to the KTV as in Victor 7. KTV as in Victor. Okay, if we did not have KTV as in Victor, let's see if I can set up the solution 20 years ago or 15, 20 years ago. 15, 20 years ago, instead of KTV, National Electric Code says, hey, I need to account for branch circuit protection. I need to account for overload. So I'd be using a fuse block plus a thermal overload if KTV didn't exist. But okay, what does KTV offer us? Here are the protection and control functions of KTV. Hey, there's a magnetic armature on the inside of this KTV that gives us that short circuit protection that National Electric Code says is required. Also integral into the KTV is thermal bimetallic overload protection. So, hey, I just said I've got BCPD and I've got overload protection. Hey, what else do we get? Oh, there's a disconnect. The rotary knob on the front of it allows us to engage or disengage the circuit. And yeah, it's a manual controller. It requires for someone to walk up to it and manually turn that knob. So the illustration that I'm given in the right side of the slide says, hey, on the line side of a VFD, I'm gonna have some sort of a switch or protection disconnect switch leading to the VFD. And on the load side of the VFD, in this circumstance of 3 motors, I've got the ability to comply with KTV7. Now, visually,
Jason?
Go right ahead.
A quick question here. There was a question on how do you set the overload for that?
Good question. Visually, I've got a picture of the KTV and V7 on the screen. To the left of the black rotary knob is indeed a FLA dial, in which you're taking a screwdriver tip and merely dialing in the actual FLA of the motor nameplate. There is no calculation necessary by the user. The thermal overload protection integrated into the unit is already factory calibrated at 120% to go into a time curve once it sees an overcurrent. So just to reiterate, what I had just said was, hey, there's no calculation necessary. You're merely going to read the motor nameplate of the FLA value and dial it in to the left of the rotary knob using that dial and dial it in the actual FLA. So that's the overload question. And just finishing my point about the illustration, on the illustration there, I see 3 KTVs kind of separated just for the aesthetics of the picture. In actuality, hey, I'm going to have 3 KTVs right next to each other, and I'm going to use bus bar to pass the continuity across all 3. So we've got bus bar available for this stuff, and I'm going to feed it with a supply block. So I only got to feed it 1 time. So that kind of gives a projective of that visual. Okay, so let's back up a second and say, okay, well, what is some of the basic knowledge that we know about VFDs already? Anyway, if it were a single motor on the load side of a VFD, hey, well, what we know about VFDs are most of them are already equipped with integral overload protection, so not even an overload would be necessary. And with only 1 motor, nothing additional is needed on the load side before the motor, because the branch circuit protection is ahead of the VFD. So yeah, I mean, if it's not integral with an overload, you're going to probably use a thermal overload. But other than that, yeah, today's single motor applications, the VFD is going to take care of all of it. However, what we keep reiterating, that National Electric Code says, hey, you got 3 motors on the load side of 1 controller. Each motor is going to require an overload. So I've got to have an overload for all those motors. Each motor is going to require short circuit protection. And so I've got to have BCPD and overload for each circuit. So that's where the KT7 1 component selection can comply with the requirement of branch circuit and overload all in that 1 device. So that's the unique flavor of KT7. And how are we doing that again? KTV indeed complies with self-protected type E, and we're using 430.52C6. KT provides all the necessary requirements for protection and control of an individual without additional protected devices. So it's either a self-protected motor controller, or we're applying group motor rules. Group motor rules meaning, hey, I'm going to have additional protection upstream of that. So on the right side, group installation 430.53C, installation rules state that the KTV7 device must be applied per the appropriate rules, which require upstream BCPD. So that's how a KTV is able to do the job on the load side of a VFD in a multiple motor situation. So I'll give, after this slide, I'll stop for the hesitation and ask KTV questions, but just kind of completing this objective number 3 of a unique controller. I said I wanted to go over the KTU7. KTU, hey, this is the UL 489 approved circuit breaker. However, KTU7 is for non-motor loads. Or the protection on the line side of a VFD. That's why I threw KTU in this section, talking about VFDs, was previously KTV7 took care of the load side. KTU7 is certainly a recommended device for the line side because of the short circuit reaction time of a KTU7. KTU7 is going to see a short circuit in milliseconds, as opposed to a molded case circuit breaker is going to see it in seconds. So the amount of damage that could occur between milliseconds and seconds, hey, use a better device for the line side of the VFD. Okay, what does KTU give us? Or the typical applications? Line side, VFD, protection for power transformers. Okay, we said non-motor loads. Well, a heater is a non-motor load, so certainly UL 489 protection on the line side can comply. So that's a application. Protection for the control circuit transformers, protection for power supplies, small distribution panels. So just letting you know that, hey, we got a UL 489 kind of approved circuit breaker device. I'm going to pause for a second and say, hey, KTV and KTU are kind of unique. Did we have any questions on KTV or U?
Yes, we
Well,
did.
if you want to have if you have any questions, just write it in that area, the question area.
Yeah, we do have some
John,
questions.
you had a question?
Jason, can you open up your chat box or the question box?
Sure can.
Then you can just look at them. I put some in red flags and orange flags. Probably need to go down to the bottom of it. You see them? Or do you want me to read them to you? Rich,
Yeah, go ahead and read them to me.
Rich, go ahead and read them to them.
Okay, thermal overload protection is not required in VFD applications because VFD has this feature built in. That's correct. Let me see what we have here.
Oh, let me expand on that second. We went over a single motor load, which, yeah, they're typically integrated into a VFD where you don't need an overload. It's very unusual that you'll have to do your own overload. And let me expand on why I keep saying thermal overload. A thermal overload is merely bimetals on the inside, and that megahertz from the VFD is not gonna, the bimetals don't care. As opposed to the other kind of overload relay is a solid state overload. Solid state overloads have an integrated circuit board, and the integration of that circuit board is typically programmed to be looking for 50 cycle and 60 cycle. Well, that megahertz from the VFD is going to play havoc on that 50-60 requirement, and that's why a solid state overload is not good with VFDs. So I digress a little bit on that one.
Okay, another question is a KT7 doesn't require a convenience contactor for signaling when you have an auxiliary contact, correct, or auxiliary accessory? And I guess the answer to that would be yes. You only use the contactor if you want to remotely operate the device from a remote push button or whatever. KT7, if you have if you're doing it manually, does have the ability to put an aux contact in there that will follow the trip or would follow the operation of the contactor on or off.
Roger that. Totally good answer, and you summed it up in saying that the contactor is merely a means of energizing or de-energizing from a signal as opposed to manually operating that dude. Yeah, auxiliaries and trip contacts exist on that KTA7 as an offering.
Next question is, can you bypass the VFD if necessary?
I think that is more of a circuit question from a product capability question. So I'll kind of bypass that question.
Yeah, and the answer is yes, they can. You know, obviously with contactors, you can do three contactor bypass isolation. So next question is, please give examples of application with one VFD and multiple motors. Why not use one VFD per motor? And that would be, I guess the answer would be to that one, if your drive can handle the three motors and they all run at the same time and at the same speed, this is a way that you can actually have three motors being controlled by one VFD as providing three VFDs for that application. So it's a cost issue in that particular case.
Yeah, we actually have a customer that makes shaking machines, and they're all very small fractional horsepower motors, but he wants to control the shaker with a VFD. So we've actually got one drive, and we happen to be the Danfoss rep for drives, controlling 5 different motors. They're all small motors.
Next question would be, still not seeing what the short circuit ratings are. We'll be going to that very, very shortly. And do VFD manufacturers allow multiple loads for one VFD? The answer to that is yes. KAIC ratings, we'll be going for that. Is it treated as taps? I'm not sure I understand that question. Jason, is it, I guess if we,
You're looking at the tap rule with the multiple motors, Rich.
okay, oh, I see. I got you, yes. Okay. And we'll be talking again, most of these are AIC ratings. So, and how to protect the power, and how to protect the power line side of a VFD. And we went over that, I think. That was the KT7.
Right, right. A lot of the VFD manufacturers will provide recommendations in their user's manual in regards to what they want on the line side for protection. Some of them will say, hey, I need semiconductor fuses and to that sort, which, you know, they just want fast acting response to a short circuit. And that's why I recommended a KT7, but you got to remember KT7 maxes out at 30 amps.
And for everybody's information too, if you're looking for more information on the KT7 in the handout section, you can see there's 3 handouts, and I think we put a white paper in there, did we not, on the use of KT7 with variable frequency drive? Oh, it's just a PDF. So that information is available for everybody. You can actually download that from the web right here. Are there any other questions? Can we go on?
All right. I saved the best for last. Everybody seems to be asking about KAIC ratings, and indeed, that's what objective number 4 is. Identifying SCCR capabilities within our KT7 kinds of controllers. So, you know, I didn't show the offering page of our most popular KTA7, and that's kind of what I'm doing here. I'm setting the stage of what KTA7 does for us before showing you the ratings. So KTA7, from the selection page, I've got KTA7 25S or 32S, S as in standard interrupting capacities. You see there in the black title bar. Moving to the middle section, 25H and 32H as in high interrupting capacity. And then lastly, the largest of a 45H, kind of a frame size, also high interrupting capacity. Well, so what's the difference? What's standard interrupting versus high interrupting? When we look at the SCCR ratings here on the next screen or 2 or 3, you'll find that KTA7 typically will allow you a 65 KAIC offering, and that'll be predominantly in the lower ranges. So yeah, you'll see 65 in the lower, but as you get in the higher, as you increment in the higher ranges, okay, the KAIC value goes down and then it eliminates after a while. So that would be the reason to move up to the next size product or a higher interrupted rating kind of product. So that's the difference between standard and high, is that in the lower amps, we can get by, but if you're not achieving the interrupt capacity required, you're going to have to move to a higher interrupting. So that was the offering page. Again, what does a KTA7 do for us? You know, you can apply, it's all in how you apply the product. In that, I'll show you the top of the column headings in just a second here, but you can apply it as a manual starter. Somebody's got to walk up to it and turn it on, to where if you're applying those rules, hey, there's no upstream protection. It's just a manual starter depending on the rules you're applying. You can apply it as a manual controller for group installation, meaning, hey, I got groups of starters. However, if I'm doing group installation, up ahead of that group, I've got to have some sort of a branch circuit protection. Individually, I can apply it as a manual controller for motor disconnect. I can apply it as a UL 508 kind of a disconnect. And then lastly, and more importantly, it can be applied as a self-protected manual combination controller type E. Now, here is the KAIC rating. Okay, where do we put this? Okay, if you were just cruising through our catalog, the selection page for KTA7s is like F4. The very next page on F5 is where we keep the SCCR ratings. Same kind of pattern for KTB and C, is that we'll provide the selection page, and the very next page is going to be the KAIC. So reviewing what we can accomplish with 25S and 32S, standard interrupting capacity, kind of a range here. looking at the column headings, the top of the column headings is what is important about this page. And you've got to understand, well, how are you applying this device? The approval for a KTA5 or KTA7 ranges from the easier application on the left and ramping up to a more stringent application to the right. So simplistically on the left, manual starter, manual motor controller, manual motor starter, absolutely. If I look down the column, all of those KTA7 controllers have a KAIC rating, and under a 480 volt, 480 delta, you notice that I can get 65 KAIC all the way down to the 10 amp model. So as a manual motor starter, sure, it's got some short circuit protection there, and that's the easiest application, because as a manual motor starter, there is no protection under those rules. It's just a motor starter. Moving over one column to a manual controller for group installation. Now I've got group installation rules in that, okay, looking down the 480 volt column, yeah, I can get 65 KAIC all the way down to the 10 amp model. Now I still got ratings for the 16 through 32 amp. Yeah, for group installation, as long as there's upstream protection, I'm still getting KAIC approval on this product alone. Moving one column over in the middle, now I'm a motor disconnect. So just note, how are you applying the product? So knowing those kinds of criteria. Again, there's my ratings right in the middle of the page, 65 down to the 10 amp model. Okay, now I'm at the 600 Canadian perspective. Okay, now as I get into the higher amps, okay, I missed the boat on a -29A and a 32A. I got to use something else down in the page, which is on the next slide or two. But okay, suitable for tap conductor protection. That doesn't come up very often, very unusual circumstance, so we'll skip over that one. And then lastly, on self-protected type E, that's the one that we're totally interested in the far right hand column. I need to point out to you, if you're using 480 volt, no longer is it a delta connection, it's a Y connection at the top of the column heading. I've got the approval for 480Y that, yeah, if I'm a self-protected manual combo controller, hey, it's a combination starter. I can still get 65 KAIC with that device by itself with a TE adapter on the top of it for the 2-inch creepage space. But agreed, that's what provides me the self-protected type E approval. However, as you notice, I get into the higher amps of -20. Well, okay, I'm only getting 10 KAIC at -20. A 25, nope, don't get type E. 29 and 32, nope, don't get type E. So what would I do? Let's move to the next page to a 25H, 32H, high interrupting capacity. Let's just jump all the way over to the right because we were talking about self-protected type E. This table's set up on the same page, so you got those 5 applications across the top. But going over to self-protected type E, going up, previously I was only getting 10 KAIC with a -20 amp model. I'm looking at a 25H 20 amp model. Instead of 10, I've got the potential for 65 KAIC. That's what high interrupting capacity did for me on that option selection. And then previously on the 25S, I back up and go, hey, if I had a 15 horse 460 volt drawing 21 amps, hey, this -25 model is not going to carry a type E approval. I've got to go to the 25H-25A for 21 amps. Now I can be self-protected type E. So just knowing how to use this table for the approvals, that was an example. Get into the higher amps. Hey, now a 29, I can't get a rating on a 29 or 32. Oh, I go to the bigger product. 45H is bigger in size. Hey, well, I can get 65 KAIC at any of those ranges now. So that kind of gives you an idea of, okay, the KAIC approval is for the component only, for the KT7 device is located right after the selection page. So up to now, all we've talked about is the controller itself. And being that we're talking about controller themselves and KAIC rating, yeah, let's flash up that KTV as in Victor 7 of what kind of KAIC approval can I get on a KTV product. I'm looking down here and I'm looking, okay, I've got a -25, -25, that's going to give me a current adjustment range of 18 to 25 on that FLA dial. So yeah, I can still get 30 KAIC under a 480Y situation. -29 and 32 doesn't carry that kind of approval, but tells you, hey, I can get 65 through most of the range, 30 on that 15 horse unit. So yeah, there's the KAIC on KT7. Taking it one step further, just to cover KAIC on that last controller for KT7, hey, right on the selection page of the 2-pole device or the 3-pole device, yeah, we've got the capability of getting up to 100 KAIC on those lower 100% rated devices. That's what this footnote is. Footnote says, hey, these are 100% rated. These other 12 amp and larger are 80% rated, just like a regular circuit breaker. But agreed, I can get 100 KAIC on those 100% rated devices, or I can get 65 KAIC on those 80% devices, just like the regular circuit breaker. So again, that's on the actual selection page of the KT7. Okay, well, that was controller only. Well, what if I wanted to add a contactor because I needed to send it a signal remotely? Now I've got, hey, these two components have been tested in coordination with each other. So now I've got a KAIC table that not only gives me my motor controller, but it gives me the minimum contactor size that's necessary to meet the approval. So as we go through the column headings here, okay, manual controller group installation in this first column, yeah, 480 volt delta versus combination. Hey, now we're talking about type F and type E. But look under type F, now we're talking about type 1 and type 2. Well, doggone, what's the difference between type 1 and type 2? All right, I'll explain that in just a minute. But just reviewing the KAIC table for a KTA7 plus a contactor. Okay, this is the view of the 25S controller plus a contactor. I mean, it's all about using the table and how you're applying it and self-protected, those kinds of rules. Okay, you'll see that, yeah, we can get type F, but can't get type E right here plus the contactor. So as I move to the next page and get out of the 25S standard, now I'm in a 25H high capacity. Yeah, here's the ratings of, if I'm going to use this high capacity controller, here's the minimum size contactor. Now I've got a few more options. Now I can see what my capabilities are when I've got both the controller and the contactor. Down at the bottom, I basically reiterate the 45H plus the contactor. So these are both components. These SCCR ratings are located right behind the CL7 CK7 kinds of assemblies. So that's where that information is located. Now, I just showed you how Sprecher and Schuh has a coordination of controller plus a contactor. Hey, I digress just a little bit to say, hey, us as manufacturers are required to submit a spreadsheet to UL so that UL could keep these spreadsheets posted on their public website. So what I'm saying is, hey, you can go look at our rating spreadsheet and table that we submitted with UL, and just go to ul.com and search short circuit combination motor controllers, and you'll find all the different manufacturers listed with the different spreadsheets. And absolutely, you'll find Sprecher and Schuh CL7, CLT7, CL8 kinds of spreadsheet approvals. So I digress just to let you know, hey, you can go to a public UL site to see our spreadsheet as well as all the competitor spreadsheets. So now looking at that KTA7 plus a contactor, I had noted on the previous page of type 1 versus type 2. Well, what the heck is type 1 versus type 2? So let's break that down in that when you submit a product to UL, there are certain test requirements to meet type 1 and to meet type 2. And let me generalize that for you. Under type 1, the number one priorities for any of these products are safety and protection. Safety and protection. So first bullet, under short circuit conditions, contactor shall cause no danger, needs to be safe. Second bullet under type 1, under the fault current carrying parts may not move. That means that KTA7 will not explode and throw plastic pieces everywhere, will not move. Under a type 1, damage to the contactor is acceptable. And under a type 1, hey, it may not be suitable for further service, meaning it's there to protect you from the short circuit, but beyond the short circuit, nope, type 1 doesn't say it has to be reusable, so it's not reusable. Let's compare that to type 2. Type 2, hey, it's got to be safe. Hey, it can't throw parts everywhere, so you're safe in protection. And number 3, instead of not having the ability to continue, under a type 2, the device shall be reusable, but type 2 doesn't say for how much longer. There is no life test required after that. So it says, hey, I'm going to be safe. I'm not going to throw parts everywhere, but hey, after that short circuit, I'm going to be reusable if you coordinate with type 2 component selection. So type 1 says, hey, I'm going to protect you, but you can't reuse it afterward. Type 2 says, hey, I'm going to protect you, but you can reuse it afterwards, but I'm not guaranteeing you how much longer afterward. Now that was UL type 1 and type 2. What are the test requirements again for self-protected type E? Because under those charts, type 1 and type 2 was a type F kind of coordination. Type E says, here's what type E says. Type E says, hey, do not require branch circuit protection upstream because it's integrated already. Hey, coordinated overload and short circuit protection. Well, that's already in the device. There shall be no welding of the contacts allowed from these test requirements. Requires a disconnect to where that's complied with. Here's the kicker for type E 508. Must pass a UL life test after the short circuit. So let's put this together again. What we just said was, from a short circuit summary of what is type 1 versus type 2. Type 1 meets UL requirement, says, hey, it can be damaged, but not reusable. So, okay, that's good because it gave me the protection and didn't hurt nobody and was safe. Moving a step further is type 2 that says, hey, I'm going to be reusable after that short circuit, but there's no guarantee of how much life you're going to get with for that product after the short circuit. So, hey, I can reuse it, so that's better. And then type E comes along and says, hey, all that's good, but hey, there is a life test after short circuit. So there is a defined life test after short circuit, in that if I were to rate the selection of components, I'd say a type 1 is good, a type 2 is better, but a type E is best because you're going to have a defined life after the short circuit. And so as I sum this up and say, hey, I was trying to stress, the advantages of self-protected type E, potential up to 65 KAIC. On this screen, I give you a typical molded case circuit breaker as a comparison to say, okay, when you're buying a traditional combo starter, or you got to spell out exactly what KAIC you're trying to achieve, because if you're not careful, they're going to comply with a circuit breaker down here at the bottom. You'll see under 480 volts that, hey, it could be a 25 KAIC kind of a breaker. It could be a 35 KAIC kind of breaker. Or you could say, hey, Mr. Customer or Mr. Manufacturer, I need 65. So you got to tell them up front about what you want, and you understand what you may be getting with a molded case breaker. So it's all about being specific. What we had noticed in KT7 kinds of product is that KAIC is typically going to be 65 at those lower amps. And when you get into the higher amps, you do have the potential to get up to 65. So those where your advantages are as in comparative to traditional versus a type E kind of a starter. So now I covered SCCR. I'm thinking we probably got a few questions. So I'll pause right here and ask for questions and see if I can help.
All right, there's a couple of questions we've got. This is the entire unit 75 degrees C rated or 90 degrees C rated for the KTA7 or KT series?
Okay, I heard you spit out some temperature values, but I gotta say that the contactor and the controller are merely going to comply with what UL says that we need to comply with, which is up to a 60 degrees C. 75 sure sounded hot. So I'll just reiterate the standard approval of the products themselves, which is going to be up to a 60 degrees C.
Okay. Next question. It says this question might have a commercial reason. Why is the KTU7 more expensive than KTA7s? Is the answer about interrupting capacities?
It's about
the KTUs are not. Yeah, go ahead.
It's about approval and complying with UL 489, that the design to comply with 489 like a circuit breaker and give you 489 is what creates that additional cost.
Okay, is there any other questions? All right, I want to thank everybody for their time today. I really appreciate it. And again, you'll be getting contacted by us next day or two on this seminar. And if you want, please download these handouts. On the very bottom of the screen, there's handouts right there. And you're able to just click on it and receive as a PDF.